From the course of Power and Energy Technology and Smart Grid, I'd like to present about how the blockchain technology can impact the smart grid technologies. And I'm Kaung Si Thu. As the nature of the smart grid, like it has a centralized platform systems, or it uses agents to supply services, the control operation and administrations, and it become more difficult as technology is more advanced and a complexity of the energy resources. Among the challenges faced in the smart grid, I'd like to point out the five main challenges that has a relationship with the blockchain, and those are the security and privacy, data processing management, and the flexibility of the grid balance, grid administration and operation, and relation among the stakeholders. So how does the blockchain related with the smart grid? Well, these are the challenges from the smart grid that the blockchain can able to improve, which are the margins and supplier is to find the expected amount of energy from the generations. And because of the variety of the variables, the information is very large and is to improve grid management, extensive the collaboration on producer, merchants, consumer, and distributors. And the generations from the smart grid and consumption imbalance can cause by the technological point of view or the physical issues uh, result from the failures of some locked network components, the interference from the outside sources such as the sabotage and the natural disasters. So, another point of view, there are technical issues like the malicious attack, frequency variation, overload and synchronization losses, and voltage drop. So from the another issue is the quality, the security and compliance control, and the effectiveness of the management mechanism in the smart grid. So like a significant amount of information is created and exchanged around in the smart grid node, and to prevent the abrupt and unforeseen power supply interruptions. And but the several smart grid domains are engaged in the process, and the data that are gathered tend to be the extremely fast, and also the correct data must be provided as frequently to get a feasible and in accordance with the regulatory requirements. So functioning of the grid is the decentralized. It has to be decentralized, and the grid operation may be made with localized by decentralizing the management and the user information, and also devices that gather and monitor data such as the business management units and scatter and advanced media infrastructures. And more effort is needed to promote collaboration between decentralized and centralized bodies. So that's why we use the blockchain technologies. And operation and management is to provide the safe and secure problems and scan to receive data from remote terminals and communications so that they can record in the data and store in the centralized control center. So, and security threats are very specially vulnerable to centralized data and collecting and holding the data. So it's the problem of the current smart grid systems. And most significant and hardest concern is confronting the present smart grid is the safety. So, like, how does the blockchain can help? But before that, we need to understand the nature of the blockchain. But the blockchain has varies based on the intention of the user and implementation. So the generalization of blockchain is economical, reliable, and effectiveness. It has a hash technology and it has the validation techniques and the many consensus mechanisms. And and the last is the transparency. So inside the block, it has a smart contract the cryptographic key, the consensus mechanisms, and the database management system. And so we here see is the how the blockchain can support, and it's supported by the consortium blockchain, and has the information security and the real-time productivity and effective tradings and efficient scheduling and operational functions that can be improved by using the blockchain, the smart grid, and blockchain control the process of schedule by the internet or maybe the 5G systems. And so there is a method for synchronizing data from the server node, which enables grid operator to concurrently monitor several energy sources and also improve in controlling frequency and then the voltage. And so we here is there are data aggregations, data security, and the smart grid data management. So along with the diversity of the distributed generation, smart grid also updating its process for collecting and analyzing concept data. So grid services are offered to a variety of energy resources through aggregator lights, and these aggregation processes however provide an operational difficulty as a result of their extensive and deployment necessity, supervisions and control. And the blockchain address the issues of centralizing data collecting that can adversely influence smart grid performance by enabling the decentralizing collections and verification of metering applications at a very various levels. So by providing the precise information on energy production, distribution, and consumptions, the smart grid data management analysis can enhance the objectives of transmission system operators. Besides, the blockchains can help with decision-making at many levels and operations, together with various underlying technologies. So smart grid has seen a series of hostile attacks in the recent years that caused partials and the whole power outage. So it can be solved by the blockchain, where blockchain is a key technology to in immutability of data and to solve the difficulties of energy security and privacy in the smart grid. A number of promising the blockchain-based solution has been put forward. So secure data distributed ledger based energy trading solutions that can guarantee anonymity for communication, bidding, and trading are referred to as a privacy-preserving energy transactions. So the framework provides for safety, transparent trading of energy futures, and protects the securities and the privacy of consumer and give distribution system operators that the power to control, trade, and enforce security regulations. And also there are permission and permissionless based blockchain system, but they approach in being used in a smart grid to safeguard privacy and energy security. So the approach enables power management along the administrators to determine the identification of the end device in the smart grid network. And as a conclusion, solution is to develop decentralized energy transactions and supply system with the help of blockchains. So these issues could be resolved by autonomous buying and selling systems that take real-time pricing and intelligence to more interactive energy market transactions, and business that are adaptable when faced with paradigm shift with swiftly adjust. Although blockchain technology is still very much in its development, it shows potential for development and experiment in creating improved smart grid technology. So these are the end of this presentation. Thank you.